video is on the basics of simplifying rational expressions. So rational expression is it's essentially when you have a fraction with a polynomial expression in the top and the bottom, and the top is that numerator and the bottom is that denominator. So in order to simplify rational expressions, your first step is to factor both the numerator, again, which is the top, and the denominator, which is the bottom, completely. So what we mean by completely is you have to pull out greatest common factors, factor using difference of two squares method, factor by grouping. You're going to factor and factor until you cannot factor anymore. Then you're going to cancel any like terms or factors from both the top and the bottom of the expression. So we're going to take a look at 4 examples, and we would like you to try some on your own. Following along in the notes, this is on page 3. We're looking at example 1. We have 40x plus 20 divided by 10x plus 30. So I noticed that none of these x's have a higher exponent. So I know I'm not going to need to do any of my difference of two squares or anything like that. However, remember, our first step is to always factor by looking for a greatest common factor. So between a 40 and a 20, I know I can take out a 20. So when I pull out that 20, I'm left with a 2x plus 1, because again, 40x divided by 20 is 2x, 20 divided by 20 is 1. So that one placeholder is very important. And the same thing here, between a 10 and a 30, I'm able to pull out a GCF of a 10. And now I'm left with 10 times the quantity x plus 3. So we're looking for like terms, meaning 20 or 2x plus 1, 10 and x plus 3. These are the factors that we're looking to cancel. So what I do have is between a 20 and a 10. These are able to cancel out because 20 divided by 10 just gives me 2. So what I have as my final answer is just a 2 in the numerator with that 2x plus 1, and then we have the x plus 3 in the denominator. Again, and that is because this 20 divided by 10 gives us that 2 in the numerator. Let's take a look at example 2. Again, we want to simplify this expression. The numerator is an x plus 4. I do not have a GCF. I do not have an exponent greater than 1, so I cannot factor that numerator anymore. However, looking at that denominator, I have an x squared minus 16. So this is going to be able to be factored a little bit. So looking at x squared minus 16, 16 is a perfect square, x squared is a perfect square, and I have a subtraction sign in the middle, so this is our difference of two squares. So this is going to factor as x plus 4 and x minus 4. Again, it doesn't matter which comes first. So now I look to see what's the same on both the top and the bottom. So looking at that, I have an x plus 4 on the top and the bottom, so they're each going to cancel out, and then I'm just going to be left with that x minus 4 in the bottom. And then we still need something in the numerator. Again, x plus 4 divided by x plus 4, so we're canceling both of those out. That's just going to leave us with a 1 in the numerator. So we're canceling out any like factors. So now looking at example 3, we want to simplify. So now looking at example 3, we want to simplify this entire expression. So sometimes it's easier to do your work off to the side and then plug your simplified version or your factored version back into the fraction to simplify. So looking at that numerator, we have x squared minus 2x minus 3. We can use our shortcut method to look for two numbers that multiply to negative 3 and add to 2, or negative 2, because we have that leading coefficient of 1. So the numbers that multiply to negative 3 and add to negative 2 are negative 3 and 1. So negative 3 times 1 gives us negative 3. Negative 3 plus 1 gives us negative 2. So that top factors is x minus 3, x plus 1. Similarly, numbers that multiply to negative 6 and add to negative 1, that is negative 3 and 2. So we have x minus 3, x plus 2. So I'm simply going to plug these back in to both the top and the bottom. So we factored the numerator, we factored the denominator. And now we can look to simplify. So I'm looking to see if any of my factors are the same. I can see I have an x minus 3 on both the top and the bottom, so I'm going to cancel those out. And then what I'm left with is my x plus 1 over x plus 2. Notice my x's do not cancel. We are only canceling the factors that are the same. Because these are being added to the 1 and added to the 2, we cannot simplify the x's. We're only simplifying things that are being multiplied together. And for our final example, example 4, we're going to simplify again the expressions. We need to factor the top completely and factor the bottom completely. So looking at that numerator, 2x squared plus 10x, the first thing I see a GCF. Between a 2 and a 10, I can take out a 2. Between an x squared and an x, I could take out an x. So my GCF here is a 2x, and then I'm left with x plus 5. Now we have to use the long method to factor 3x squared plus 16 plus x plus 5. You still need to find two numbers that multiply here to 15. You have to multiply your first and your last together and add to 16. So, but you cannot just say that this is x plus 15 and x plus 1. Again, if you need that refresher on factoring with a GCF greater than 1, please go back and watch that video example and do some extra practice. But our denominator factors now as 3x plus 1 and x plus 5. So I'm going to plug those back in for both the top and the bottom of my fraction. And now I look to see if there's anything that I can cancel. So I can see I have an x plus 5 on both the top and the bottom. So those are going to get canceled out. And then what I'm left with is just the 2x in the numerator and the 3x plus 1 in the denominator. Now to solidify what you've just learned, I would like you to look at page 5 and try out numbers 1 through 4. And as previously mentioned, the answer key, or as you saw online, the answer key to this whole section is online for you to check as well. But please try these on your own. This will help solidify your factoring. Please note, again, if you see something with 4 terms, you jump right into factor by grouping. And you must always look for a GCF first when factoring.